Who's never used any kind of version control, Git or anything? Okay. So why do we want to use version control? What's the point? I take backups of my machine. I'm not going to lose anything. I could. Huh. Yeah, I guess I only take backups every day. What if I'm working along, I finish something, great, this feature now works. I've saved it. Now I'm going to make some more changes. Oh yeah, I'm really humming along in this new feature. And then I realized I'm going in totally the wrong direction. I wish I could back up to how it was before I started this task. With version control, I could. I could always get back to previous versions, assuming that I actually add new versions at reasonable times. If you don't commit often enough, you'll often wish you could get back to when it worked. So a lot of times, the way I tell is it time to commit yet. If I make something work that didn't work before, every time I make a new thing work, I commit. Sometimes I feel the need to commit when I'm only halfway through something and I make kind of a work in progress commit. So that's one reason. Were you going to say something different? More or less that. Also, it can kind of serve as documentation. You look back through your commit messages and you can see what you did in what order. Again, assuming your commit messages are not things like updates or what was the other example? It's the other one I see all the time. Changes, yeah, stuff like that. Say what you did. Say what the commit does. So also, suppose I've got a rather large project and I see this function or this line of code or something. I'm like, is that even doing anything? That doesn't seem to be doing anything. But I'm afraid to take it out because maybe it's super important. If it's in version control, you can find the commit where it was added, and you can see it in its original context because so much has been added around it now you can't even tell what it's supposed to do. But if you can find the commit it was in, what the commit message was, and what other things it's related to, you can get an idea of what it's supposed to be doing, and then you can better evaluate, is it okay to remove it now? Because maybe it was for some feature that was totally removed. Yeah?
Could you also just comment it out for a second and then run it and see what happens?
Well, you could, but what if the thing that triggers it isn't necessarily that common? Like it only runs if you entered a number that's too big or something like that. So that's risky. If you've got a good test suite, you can run the tests. You comment it out, run the tests, and hope that works. But it's nice if you can actually see where it was added and see what feature it was kind of part of when it was first created. But yeah, good suggestion. So brief discussion about what version control is itself. Git is a version control system. It's a distributed version control system, which means that the entire repository is always on your machine. You always have a copy of the entire thing. You can go back to previous commits without having to talk to a server or anything. You've got an entire repository living just on your machine. So what happens with all these commits we usually do? Let's do a git status. I see changes not staged for commit. These two things. No changes added to commit, use git add. Come on. There we go. So here's what's going on. Everything to the left of the dotted line is happening on your laptop. Any changes you've made since the last commit are in your working directory or working tree. That's the files as they are now. Everything else is in that .git folder, which is hidden and you never need to worry about. Your working directory is the directory as you're working with it now. It contains all the changes you've made since your previous commit. But Git doesn't know about those changes yet. That's what add is for. So when you use the add command, git add, we'll do git add dot. Do a git status now. We see changes to be committed. Now we've added them to Git. They're in the index or staging area. So Git knows about them now. It's tracking the changes. They're there. But we can't get back to them later yet. We instead need to create kind of a snapshot or a checkpoint for this thing that we can always get back to later. Like suppose you're halfway through some super long level in a video game. You get a checkpoint. You go on. You die. You go back to the checkpoint, right? Not back to the very beginning. So you create a new checkpoint every time you make a commit. So let's commit. And that's when we choose a message. We need to label this thing so we know which one we're going back to, because it's going to assign this horrible looking hash. So git commit message. What was it? This is, well, heck, let me check git log. What was my last commit? My last commit was updated special paragraph. Hit Q to get out of git log. Git commit message. Update heading when the form is submitted. Great. So all the changes since our previous commit were in the working directory. We added them, which put them in the staging area. Then we committed them, which put them, essentially created a checkpoint for us. And now they're actually in the repository. Head, as it's labeled here, just means my latest commit. So now those changes are my latest commit. But all this is happening on your laptop. When we first created the repository on GitHub, remember we copied a couple of commands to the terminal. The first one was git remote add. Specifically git remote add origin and then the GitHub URL. So you can have remotes that you sync your repository to. In other words, the repository can also live on other computers and you can sync it with them. So those are your remotes. And typically your main remote is named origin. So when we say git remote add origin, origin is just the name we choose for it. Git remote add is the command. So git remote add origin, that gives us a remote called origin, which is GitHub. And the very first time that we pushed, we said git push -u origin master. So we were telling it where to push, but that -u tells us from now on, that's the origin I want to sync with, or that's the remote I want to sync with. So git push takes our repository as it lives on our machine and moves it up here. Cool. We'll be doing it over and over. It'll become second nature, I hope. Questions? Yeah.
So will all the assignments that we would be pushing, will those all be done on the master branch?
Yeah, I mean, you can do it differently if you want to, but if you do, merge it back into master, because that's, I'm not going to go looking for other branches unless you tell me. Yeah.
So you would have multiple people working on the same thing and then push it to the same?
Yep.
Okay. Is that what the remotes thing is?
Yeah, but I mean, you can do it even if you're the only one working on it. So it is actually useful to use Git. I do it even if I'm the only developer on a project for all the reasons that I stated earlier. And I still typically sync it with GitHub because let's suppose, hypothetically, you're teaching a boot camp and you're on a stage that's about 4 or 5 feet tall off the ground, and you're in the middle of teaching and the desk was a little too close to the edge and it falls off. It falls off in such a way that your laptop ends up on the bottom and the desk lands on top of your laptop, ruining it, and it's a half hour before the Apple Store closes. So you run, you get a new one, and you come right back. Well, guess what? All the work was pushed to GitHub. We're back in action in no time. Hypothetically. Oh, show and tell. This is the very monitor that fell off that stage too. This is not the laptop. The laptop was ruined. The monitor was just kind of beat up. It's got a couple flaws it didn't have before, and if you look underneath, it's bolted on with something other than what it originally came with. But yes, the monitor survived the fall. I'm pretty impressed. I'd had it for like a week, so I was really happy. Hypothetically. So yeah, if you lose your laptop, that's bad. Or if you say, get it stolen in Brazil. Didn't happen to me. Happened to someone else at Fretless. That was bad too. But all this stuff was on GitHub. So really no big deal other than the fact that it was a $3,000 laptop. But, you know, better than like getting sued by your customers and stuff. Hard drive was encrypted. Their data was all fine. Yeah, good question. Anything else? It's good stuff.